Hello everybody, welcome to another video lesson. Today we're going over three-dimensional space. All we're going to do is plot points and vectors in three-dimensional space. That's it. So let's hop right into it with our three-dimensional coordinate system. Okay, we have X and Y, we're used to that, but now we're going to take a look at the Z-axis. The Z-axis. So you guys are used to X and Y, so this quadrant right here that is closest to me on this kind of blue plane of X and Y, that's what we're normally used to looking at with our positive Y going off this way, positive X going off that way. Okay, but it's changed a little bit, so you got to kind of reorient yourself here. So our X and Y are laying flat, okay, and then our Z-axis is going to be going up here, okay? So what you see here, this is going to be the positive X, the positive Y, and the positive Z. Okay, so going back this way would be negative X, going down would be negative Z, going off to the left here would be negative Y, all right? So our Z-axis is giving this sort of depth to our XY coordinate plane. Now our points are represented, as you can see here, points are represented in an ordered triple, all right? So ordered triple, that looks like X, Y, and then Z is how they're ordered. So here, we'd have X would be 3, Y would be 4, and Z would be 5. All right, so that is our ordered triple. And in order to graph these, first thing we want to do is move along the X and the Y plane first. Okay, move along X and Y plane first, and then we will move up or down, like you see here with this red arrow, to find the point. Okay, so we're going to move along the X-axis, the Y-axis, and then from there you move straight up or straight down the Z-axis in order to plot your point, all right? Now, I mentioned earlier the word quadrant, okay, which is what we are used to, okay, but now with this three-dimensional space, we actually have octants, okay? We have 8 areas now instead of just 4. You can kind of see what we used to have, 4 in this blue square here, but now we've got a quadrant below and a quadrant above each of those quadrants. Or I guess you have an octant below and an octant above when you account for the Z-axis, okay? So now instead of 4 quadrants, we have 8 octants here that we can refer to. Okay, let's take a look at our distance and midpoint formulas in our three-dimensional space. Remember, our distance formula for two-dimensional space looks something like this, and it is very similar with our three-dimensional space. All we do is add on the square of the difference of our Z terms here, or our Z coordinates, okay? So that third coordinate in our ordered triple, that Z coordinate, all we're doing is adding that on to the very end of our distance formula for 2 dimensions. And similarly with our midpoint formula in 2 dimensions, now we've got x1 plus x2 divided by 2, and then we've got y1 plus y2 divided by 2. Very same thing as with our distance formula. It stays the same. Now we just add this z term onto the end. So we've got z1 plus z2 over 2. Okay. So all we're doing now is accounting for this third coordinate information in our 3D space. So that's it. Let's get into a couple examples. We've got plotting a point in three-dimensional space. We've got -3, -4, 2. Okay, so again, first thing we're going to do is move along the XY axis. So -3 is going to be going back 3 units here. Okay, so we can see our -3 here, and then we move to the left 4 units because, again, this is positive X, positive Y, meaning this would be negative X back here, this would be negative Y, and this is positive Z, meaning down here is negative Z. Okay, so now that we've found kind of this point here on our XY coordinate plane, then we'll just go up into our Z plane here, or into our Z axis, 2 units, and this is roughly where this point would be plotted, okay? You got to kind of estimate with this, because think about going 2 units up and then going over back to this intersection between the XY. All right, now let's take a look at plotting this point, 3, 2, -3. So again, we're going to go +3 in the X direction, +2 in the Y direction, because this is X, Y, and Z when we get our ordered triple. And then again, we are just going to go down 3 units in the z direction, which will look something like that. So our point will be right about there. All right. Okay, now we're going to go ahead and use this in a real world scenario. Okay, safety regulations require airplanes to be at least a half mile, that's 2640 feet apart when in the sky. 2 planes are flying above Beijing with coordinates given here. Coordinates are given in feet, so keep that in mind. Okay, we got a 2-part answer here. Are the 2 planes in violation of our safety regulations? Again, our safety regulation is given here. And then if a firework was launched and exploded directly between the 2 planes, what are the coordinates of the firework explosion? So let's take care of A first. Let's find out if they're in violation of our safety requirements. So I've got our coordinates given here, and then we've got our distance formula. We want to see exactly how far these 2 planes are from each other. So we're going to have x1, y1, z1 here, x2, y2, z2 here, and we just plug those straight into our distance formula, and we'll get a square root of 150 squared plus negative 400 squared plus negative 2000 squared. Okay, that's just taking the difference of our x1s and x2s, and then the difference of our y terms, the difference of our z terms. And when you plug that into a calculator, you will find that yes, the planes are in violation of the safety regulations because they are roughly 2,045 feet apart, which does not meet our safety requirements. Okay, let's go on to part B then. Again, we've got our coordinates here in our ordered triples. Now, all we need to do here is use our midpoint formula because this firework was launched and exploded directly between the 2 planes. Okay, directly between. So it's at the midpoint of these 2 planes, these 2 coordinates. Okay, so our midpoint formula, again, given here. We're just going to add our x's and divide by 2, add our y's, divide by 2, add our z's, divide by 2. So I've got 750 divided by 2, negative 100 divided by 2, and 58,000 divided by 2. And when we do the math there, we get 375, negative 50, and 29,000. All right? So that is it for this video, guys. A nice short one. Good luck with your practice.